Hello everyone, and welcome back to another adventure in electronics, robotics, and communication systems. Now, I've recently shown how to do cryptographic hashing in the open source world of GNU Octave, and by now I think you know, when we have a video on GNU Octave, a video on Scilab isn't going to be far behind. For anyone unfamiliar, Octave is an open source and free alternative to MATLAB, and so is Scilab. Between the two, I prefer Scilab for filter design, but today we're doing strictly cryptographic hashing. To recap, a hash function will take in a volume of information as an input, and its output will be a digital signature of a fixed length. Among other things, this technique is used to secure different blockchains, and many consumer, industrial, medical, and military electronics also use this in their security layer. I'm going to show an example of this by opening the Scilab software, waiting for its terminal to load, and issuing my first command. And keep in mind this is case sensitive. I'm going to start off by typing hash, parentheses, hello world, within quotes, comma, SHA-256. By the way, you can get a list of these commands in the video description and on the unboxing-tomorrow.com website. The first parameter in this command is the string literal that we want to hash, and the second parameter is the name of the hashing function. Although in this software you can also do cyclic redundancy codes, or CRC, or the popular MD5 checksum. SHA is considered more state-of-the-art and more secure, and if you want to see this done at the hardware level, be sure to leave your feedback. The output of this one-way hash is a hexadecimal string, and if we were to decode it, we would get a list of binary bits that would be exactly 256 bits long. We can do the exact same thing using variables. So I'm creating a variable called myString, assigning it the string literal of hello world. Then I'll press enter and type in hash myString, comma SHA-256. Between both commands, you can see that the output is identical, and because SHA-256 is a national standard, both Octave and Scilab have generated the same report. Finally, if you want to hash the content of an entire file, you will need to use Scilab's mopen function to create a file descriptor and then save that file descriptor to a variable. Let's do that now by typing fileDescriptor equals mopen temp directory plus / myFile.txt comma RT. And again, you can copy this command directly from the description. TMPDIR is short for temp directory, and you can consider this the working directory for Scilab. The plus sign performs a string concatenation, and myFile.txt is a file I prepared before making this video. In the second parameter, we have R for read, followed by T for text, as opposed to reading a binary file. When this command executes, temp directory will be replaced by the path to your working directory, and the file descriptor variable will be ready to use. Secondly, we type in hash, parentheses, file descriptor, comma, SHA-256, press enter to read the result, and when we're done with that file, we need to close it by issuing a mclose, parentheses, file descriptor. If you are programming in other languages like C or Python, you will have entire libraries at your disposal for doing this, but if you're doing scientific workflow, I think you'll find this useful.